Continuing with the excuse me, with the Algebra 2 review for Unit 4, number 19, and it says the product of two positive consecutive odd integers is 63. What is the sum of the two integers? So the product, okay, so we say x equals the first one and x plus 2 equals the second one because they're odd, and odds are two numbers apart, is 63. Product means multiplication, so x times x plus 2 is 63. I'll go ahead and distribute on this side. Oh, sorry. I'll subtract 63 to both sides. That equals 0. And then I ask myself, well, you know, what times 63 gets me to, or what times 63 adds to 7, or 2, sorry, that's 9 to 7. Okay, so they add to a positive, so that one's got to be positive. That's equal to 0. It's equal to 0. So x equals 7 and x equals negative 9. Okay. So it says positive, so I ignore that one. So the answer is 7 and 9, but it actually asks for their sum. So they actually want me to just take those two numbers and add them up. So that's 16. Okay. 20. 20 says two positive numbers are consecutive odd integers. The square of the smaller, okay, so this is going to be x for the first one and x plus 2 for the second one. So the square of the smaller, that one's plus 2 bigger, right, is 13 more than 4 times the larger. There's 4 times larger, and that's 13 more right there. So now I'll go ahead and say x squared equals 4x plus 8 plus 13, and then x squared equals 4x plus 21. Subtract that over, and I get x squared minus 4x minus 21 equals 0. 7 and 3, 7 being the negative. So x equals 7 and x equals 3. Now I'm skipping some steps, but I'm going to speed up a little bit here. And going back, it says positive numbers are consecutive odd. So positive, so I ignore the negative 3. It says find the sum, so it's going to be 7 and 9. Okay, so this one's also 16 when I add them together. 21. When the first of two consecutive positive integers added to the square of the second, the result is 55. So when the first of two is added, so the first one would be x, and it doesn't say even or odd anywhere, so it's just x plus 1 for the second one. So it says the first of two consecutive positive integers is added to the square of the second. The result is 55. So it's going to be x plus x squared. If I FOIL this out, combine like terms, subtract 55 over, right? Then I ask myself, what times what multiplies to 54 and adds to 3? And 6 and 9 should do it. That's with the x, the 9 being positive and the 6 being negative, so we get that and that. So our answer should be x equals negative 9 and x equals positive 6. And let's see, they say positive integers, so we get to ignore that one. So the answer is 6 and 7, and all they want us to do is find them. Okay, so that was 21. 22. When the first of two consecutive positive even integers is added to the square of the second, the result is 70. So this is just like 20, I think. I'm just going to get it set up for you. And be careful, they only want the larger one. So even, so it's going to be x equals the first one and x plus 2 equals the second one. So it says when the first of two even ones. So the first one is added to the square of the second one. The result is 70. Foil this out. Okay. And if I move everything over, it should be something like that. Subtract the 70. Again, I put this. I'll let you solve it from there. Okay. So it should be 5. 6 and 11 would get you there. All right, moving on to 23. And 23 says, write the line of symmetry, the coordinates of the vertex, the domain, and the range. Okay, so I need the vertex for all that information. So for 23, I'm going to go ahead and find the vertex. That's in the standard form. So that means I got to use negative b over 2a. So I'm going to say negative b, which is 8, all over 2 times a, in this case is 1. So that's negative 8 over 2, and that's negative 4. Okay, so when I'm looking at my vertex here, my x-coordinate's negative 4. To find the range, or sorry, to find the y value, I have to plug in. So that's 16 minus 32 plus 2. It's negative 16 plus 2, and that's negative 14. Okay. So now that I got that, I've got everything I need to answer the question. So there's my vertex. My vertex is negative 4, negative 14. My line of symmetry, which has to be written as x equals the x-coordinate. The domain is all real numbers. Remember we said that's always true for quadratics, parabolas. And the range. Okay, so for the range it's always y and then the value of the y. But for this I got to go back to the original question, and this one has an a that's positive, so that means it opens up. Okay, so if the parabola opens up, that means we're going to use the y's that are greater than that point. So the y's are greater than or equal to. If it would have opened down, I would just switch this inequality sign. Okay. 24, it's much easier. It's in the HK form or the vertex form. So I'm going to rewrite this so that I can see my h and my k. Okay. So my vertex is the point 0, negative 8. My line of symmetry is x equals 0. If you don't put the x equal, it's wrong. My range or domain, yes, let's do range here. Is now go look at the original one. This a value is positive, so this also opens up. So it's y is greater than or equal to negative 8, and the domain is all reals. Now you can write that with that double-lined R. Okay. 25. 25 is also in the HK form. Go ahead and add that 0. So my vertex is negative 2, 0. My line of symmetry is x equals negative 2. My domain is all real numbers. And my range is y. I have to do with the 0. This is also positive up here for the a value, so this is also greater than or equal to 0. 26. Y equals negative 1/3 x plus 1 squared plus 3. We'll go ahead and say that we're looking at, for a vertex, negative 1, 3. A line of symmetry, x equals negative 1. A domain is all real numbers. And the range is going to be y. Look at my y value. Now this is a negative a, so that means it opens down. Okay, this parabola opens down, so the y's are less than or equal to 3. All right, looking at number 27.